Hello, 8th graders. It's Mrs. Thompson, and we are starting in a brand new chapter today. We're actually in chapter 5 in our textbooks, and we're in section 1, and we're going to be doing example 1 today. Our objective is to identify solutions of systems of linear equations. So everything we learned about in chapter 4 is actually going to be really relevant and important for this chapter. So let's start with some definitions. We've got systems of linear equations. That's basically when you have a set of 2 or more equations. And everything that we do in this particular chapter, we're just going to be working with 2 equations. I don't think anything more than that. So just our main focus will be on 2 equations. Now the solution of a system is the ordered pair that satisfies each equation in the system. Or in other words, the ordered pair that makes each equation true. Okay, when I plug it in, it works in the one equation and it works in the other one. That's the solution to the system. Okay, so in example 1, we're going to identify solutions of systems. And we're going to tell whether the ordered pair that was given to us is actually a solution of the given system. So remember what I said. The ordered pair has to work in both equations. So here's equation 1, that's x plus 2y equals 6, and here's the second equation, x minus y equals 3. This constitutes a system. Whenever you have more than one linear equation, you have a system. So this is what we call a system of linear equations. Now, here's a bonus point opportunity. I know how you love my bonus point opportunities, okay? So do it real far down on your page so it's not going to get in the way of any writing that you need to do from here on out. But bonus point. In what form are these 2 equations in letter A? We have x plus 2y equals 6 and x minus y is equal to 3. If you can tell me what form those are in, I will give you a bonus point. Now, you don't erase. You put that far down on your page. I'm going to erase that so I have some more room to work. Okay, so we're given an ordered pair, 4, 1. Okay, now what that tells me is, remember, in an ordered pair, the first number is the x, the second number is the y. So whenever I plug into an equation, I'm going to plug in 4 for the x, 1 for the y. So let's take our first equation, x plus 2y equals 6. All right, now x, remember, is 4, and y is 1. So the first thing, remember, on the left-hand side, we still have to follow order of operations. So my choices are addition or multiplication. And you're right, multiplication always wins out. Now I can add. So the bottom line is, does 6 equal 6? Yes, it does. I'm going to put a check mark by that because it did work. 4, 1, when I plugged in 4 for the x and 1 for the y, I got the left side of the equation to equal the right side. So I know that it works. Okay, let's try it for the second equation. X minus y is equal to 3. Remember, we're still going to use x is 4, y is 1, and then we're going to do 4 minus 1 is 3. And so then you ask yourself, does 3 equal 3? Why, of course it does. Because 4, 1 worked in both equations, not just one, not just the other, but in both, we would say that this is a solution. So 4, 1 is a solution. Okay, it worked in both equations, so I can say that. Now let's look at letter B. This time, x is going to be -1 and y is going to be +2. And we're going to plug in, you can see our 2 equations. Let's start with the 2x plus 5y is equal to 8. So remember, x is -1, so that's 2 times -1 plus 5 times 2, does that equal 8? We'll follow order of operations. We need to multiply first. So 2 times -1 is -2, 5 times 2 is 10. Now I can add them together. What's -2 plus 10? And that is correct, 8. And 8 does equal 8. So it works in that first equation. That's wonderful, but don't stop. Go to the second one and let's try it out. We got to make sure that it works in both. It's not okay for it to only work in one and not in the other. Okay, so let's do 3 times -1 or minus 2 times 2. We're going to see if that equals 5. So remember, do multiplication first. 3 times -1 is -3, minus 2 times 2 is 4, and -3 minus 4 is -7. Well, you know what? -7 doesn't equal 5. So we can't say that this is a solution. What we have to say is -1, 2 is not a solution of this system. Okay? So this is a skill we need to learn how to do. You need to be able to tell if a given point works for that system. It has to work, remember, in both equations, not one or the other, but in both of them. And example B is a really good example of how it worked in one but not in the other. That means it's not a solution of that system. There has to be another answer there. Okay, that's it for example 1. If you have any questions, write them down in the margin and bring them to class tomorrow.